So I'm going to work through the second problem on a two-problem set that I made up for us to work on in class today. In class today, we started with the warm-up questions that are on the homework page of the website. I put the answers there for those of you who are at home. If you have questions on those, be sure you ask me about them on Thursday. If you are still at home on Thursday, we may try and Zoom the class. All right, the first problem on this list looks like this. You can freeze the video here if you want to try and work through that. Make sure you could. You have to balance the equation before you do the stoichiometry. This one's a little bit more difficult, so I'm going to work through this one. So if you're at home, be sure you've taken a look at the textbook assignment that I left you last class and the 4 questions that I gave you on a piece of paper handout. All right, so writing this equation, we have manganese dioxide, which is manganese 4 oxide, which is MnO2. And it's going to react with the chlorate ion. The chlorate ion is ClO3 with a -1 charge. It's time for you to begin to know these ions, so it's easier if you don't have to look them up. The permanganate ion is MnO4 with a -1 charge, and the chloride ion is Cl with a -1 charge. The IDE ending tells you that it is at the end of a binary compound, and it's always going to have a -1 charge when it's there. At the beginning of class today, we were working on charges of elements within ions, so like this manganese would be +7 because -2 times 4 is -8. -8 plus X equals -1, so +7. And chlorine here would be +5 because the oxygen's -2. There are 3 of them, makes -6. So -6 plus whatever this is has to equal -1, so the chlorine's +5. All right, so now we're going to go ahead and write our half reaction. So we know that MnO2 is going to turn into MnO4. It is important that you put the charges on when you write the half reactions because you have to balance charge in a minute, so don't forget the charges. Okay, we look at this and we see that there are 4 oxygens here. There's only 2 over here, so I'm going to have to add 2 water molecules to balance out our oxygens, which necessitates that we have 4 hydrogens because there are 2 hydrogens on the left side, but we multiplied it by 2. So 2 times 2 is 4. That's why I have 4 over here. I'm going to go ahead and balance charge while we're on this equation. So the total charge on this side is 0. The total charge on this side is 3. It's 3 because we have a +4, 4 times 1, plus a -1. So since that's +3 and I want the charge to equal on both sides, I have to add 3 electrons. Okay, then I have ClO3 with a -1 charge. It turns into Cl here with a minus charge, -1. So ClO3 -1, Cl -1. On this side, I have to add some waters because I have 3 oxygens, so I'd put 3 waters in. And then that gives me 6 H's, so I'd have 6 H pluses here. All right, so now let's talk about charge. This is 6 times 1 is 6, and a -1 makes 5. And on this side, I have -1. So I need to add enough electrons to make this side go down to -1. Since this has a total positive charge of 5, 5 plus -6 equals -1. So 5 on this side, 6 times 1 is 6, plus -1 is 5, plus -6 equals -1. So I need 6 electrons over here. So that brings us to the point where we can add our 2 equations together. Oh, well, almost. We have to multiply the top equation by 2 because there's 3 electrons here and 6 here. So this is going to become a 4. That's a 2. That's a 2. That's an 8. And that's a 6. All right, so let's go ahead and cancel out what cancels. The electrons are gone. That's why we multiplied the top equation by 2. The hydrogens are gone on this side. This now becomes 2 because there's 8 over here, 6 over here. So I know I'm going to have 2 H pluses left over on that side. These waters go away because these 4 now become 1. So you have 4 waters and you have 3 waters, which means that you've got 1 extra over here. So you're going to have an H2O here. All right, so nothing else cancels, I don't think, so we have two MnO2s plus the ClO3 plus the water, plus 2, it yields 2 H pluses, plus 2 permanganate ions, plus a CO minus. So that's our balanced equation, except that it does say up here that it is in a basic solution. And what a basic solution means is that you don't really have the H pluses that we thought we had. We have OHs. That's an easy fix. We did this last week. Since you got two H pluses here, you add two OH minuses here to cancel them out. If you did it to that side, you have to do it to this side. So two OH minuses. All right, so this becomes two water molecules because an H and an OH makes water. Now I have a redundant water. So this is going to cancel out. This is going to become one water molecule. And so our final balanced equation becomes two OH minuses plus two MnO2 plus the ClO3 minus. That's it on that side. Yields one water, because remember we had two, but one canceled out with that one, so it became one water, and two permanganates, and one chloride. All right, so now we're ready to actually do the stoichiometry. It says that we have 20 grams of this. And it says that we have 25 grams of potassium chlorate. Now, this equation doesn't have potassium chlorate in it. Remember, the spectator ions are not included. So I didn't include the potassium in the equation, but the chlorate can't be existing on a shelf by itself. So it has to be in combination with some cation, and this cation that we used here is potassium chlorate. So what we have to do is find out moles of each one of these. So if we go to a periodic table, the periodic table is going to look like this. So there's the periodic table. And manganese is 55, we'll call it, 54.94. So 55. And the others I know off the top of my head, so we'll go there. So manganese 55, so 55 and 32. Throw my calculator out here so you can see what I'm doing. So 55 plus 32 will be 87. So that formula mass is 87. And 35.5 plus 48 plus 39. So the 35.5 comes from the chlorine, the 48 comes from 3 oxygens, and the 39 comes from this potassium. So that total formula weight is going to equal 122.5. All right, so we're going to change both of these into moles. So I do it over here. I have 87 grams of MnO2 times 1 mole over 20 grams. No, over 87 grams. I did that backwards. This is supposed to be 20 grams, so it's my fault. 20 grams of this, and I'm going to change it to moles. So 20 divided by 87, 0.2298, we'll call it 0.230 moles of MnO2. For the other one, we had 25 grams of potassium chlorate. One mole we found out was 122.5. So 25 divided by 122.5 is equal to 0.204. Now, it's back at the beginning of class I was trying to teach you about how when things separate you can determine the ion concentration. In this case, since there's 1 mole of potassium for every 1 mole of potassium chlorate, you'd say there's 1 mole of chlorate. So in other words, the 0.204, since it's a 1-to-1 ratio, is 0.204 moles of chlorate also. So I'll just scratch out the K, and it's 0.204 moles of chlorate. Now, if this had been like magnesium chlorate, which it wasn't, but if it was, then this number would have had to be multiplied by 2 because of the 2 that's down here. So when it dissociates, it would go into magnesium plus 2 chlorates. And this is the kind of stuff we're talking about at the beginning of class. All right, so now we are ready to go with calculating our limiting reactant. We know that, I just start with the top one, that we're going to need 1 chlorate ion for every 2 MnO2s. So this is going to be 0.150, 0.230 divided by 2. Oh, gosh, 0.115. I made a mistake there. I'm rushing. It's supposed to be somewhere in 10 minutes. So 0.115 is the number of moles of chlorate that we would need. We have 0.204. So this is what we need. This is what we have. So do we have more or less than we need? So we have more. So that's going to be the extra. So our limiting reactant is going to be this one, the 0.230 moles of manganese dioxide, or manganese 4. And we want to know what mass of chloride ion will be produced. Okay, so our MnO2 is our limiting one. So we'll take our limiting reactant, 0.230, and we know that there is 1 Cl minus for every 2 MnO2s, and we know that there are 35.5 grams of Cl for every mole, and that's straight off the periodic table. So 0.230 divided by 2 we know is 0.115, that's left over from a minute ago. Okay, and then we multiply by 35.5, and our final answer would be 4.08 grams of Cl minus. All right, so reviewing what we did, we wrote the equation, we wrote our half reactions, we balanced the waters and the H's, then we use electrons to balance charge. We combined the two reactions, we added OH's because I'm just realizing I had that up there. You couldn't see what I just pointed to, so let's back up a little bit. Okay, so what we did first is write the equation. We wrote our two half reactions. We added waters and hydrogens, and then added electrons to balance charge. And we did that for both of these reactions. Then we combined the two equations, got them together. Then we had to adjust because it was basic, not acidic. So for every H, we put in the same number of OHs and did that to both sides. That created two water molecules here. There was one over here, so I scratched it out and made this one so we don't have redundancies, and this was our final equation. Then we needed to find which one of these is limiting, so we changed them both to moles. This chlorate came from potassium chlorate, so I had to use the mass of potassium chlorate when I was doing moles, and that was 122.5. That's the formula mass of potassium chlorate. Once I know the moles of potassium chlorate, that's also the moles of chlorate, because the relationship is a 1-to-1 between potassium chlorate and chlorate ions. There's only one of these for every formula unit. So now we took the moles of one compared to the moles of the other, so we did this ratio. It turns out we needed 0.115. We had 0.204, so that was extra. So the limiting reactant was this one. Then you write down the limiting reactant and then do the stoichiometry with what you're looking for on the other side. So 1 to 2, and then the formula mass of chlorine was 35.5. And that's how you do it. So that problem incorporates a lot of what we've done this year. There's just multiple things that you have to know how to do, and that's what we're working toward, is trying to be able to do problems that require lots of steps and different parts of what you know. So I'll stop it there and we'll post that.